Hi students, MCQ number 9. In an electrical circuit, resistor R, inductor L, capacitor C and AC voltage source all are connected in series. When L is removed from the circuit, the phase difference between voltage and current is pi by 3. Instead of removing L, if C is removed from the circuit, then the phase difference is once again pi by 3. The power factor of the circuit, the original LCR circuit. Understand? So here understanding is very much required, students. Actually all the three components are connected in series LCR, and then they are connected to the AC voltage source. First, what is removed? Only L is removed, and it is found that the phase difference between voltage and current is pi by 3, that is 60 degree. And next, L is fixed again. Now C is removed. So it becomes RL circuit. For that circuit also, the phase difference between voltage and current is pi by 3, that is 60 degree. Now, if you don't remove this L and C along with R connected to the AC circuit, in the original circuit, what will be the power factor is the question. So clearly, you have to read the problem again and again, and you have to understand. Now, in the LCR circuit, tan phi, tan of phi is equal to XL difference XC divided by R. You must remember that if you have imagined the circuit as predominantly inductive, then XL minus XC you have to write. Suppose predominantly capacitive means you have to write XC minus XL. But in general, the numerator must be the difference between the inductive reactance XL and the capacitive reactance XC. Okay. Now, in this, phi is equal to pi by 3, that is equal to 60 degree. Okay. Now, first case 1. In the case 1, what is removed? L is removed. Okay. Capital L is removed. So, in this case, what is tan phi is equal to? Instead of tan phi, I can write tan 60 is equal to. So XL becomes 0, is it not? When L is removed, XL becomes 0. So this is XC divided by R. Okay. Therefore, XC must be equal to R tan 60. R into tan of 60. You need not substitute for tan 60 also. Okay. Let it be as it is. Now, case 2. Instead of L, C is removed. What happens if C is removed? So if C is removed, in this equation, XC will be equal to 0, is it not? Therefore, tan 60 is now equal to XL by R. XL divided by R. Okay. Therefore, XL is equal to R into tan 60. Okay. So tan 60, if you substitute also, this becomes what? R into root 3. So here also, if you substitute means this becomes R into root 3. So from this, what is indirectly given information we have to understand? What is given indirectly is XL is equal to XC. This happens only at resonance, is it not? So XL is equal to XC. So this is the hint given to us. This is the hint given to us. So circuit is in resonance. Okay, circuit is in resonance. Okay. Therefore, in the original circuit, in the original LCR circuit, okay, in the original LCR circuit, we have to substitute this condition XL is equal to XC. So there tan phi we have to find out. Dear students, you have to keep it in mind. Here the phi angle is not 60. Here it is not 60 at all. But when L is removed, the phase difference between current and the voltage is 60. Again, when capacitor is removed, again the phase difference between V and I is 60. But when both are not removed, in the original RLC circuit with all the components, the phase difference between voltage and current is not 60. That we have to find out. Okay. Without finding also, now we can say or not, because it is in resonance. When it will be resonance? What do you mean by resonance? Voltage and current are in phase with each other. Understand? They are in phase with each other. Therefore, very clearly it is tan 0. Is it not? It is 0. Anyhow, I will substitute and I will prove. Okay, so this is XL minus XC divided by R. So, since XL is equal to XC and the condition is resonance, so definitely the numerator is 0. So, 0 divided by R, that is 0 only. So, tan phi is 0. Therefore, phi is equal to tan inverse of 0, that is equal to 0. Okay. So you must clearly understand that when C is removed or L is removed, the phase difference between current and voltage is 60 degree. But when they are not removed, they are in resonance. At resonance, both voltage and current must be in phase with each other. Therefore, the phase difference must be equal to 0. That you have to understand. Afterwards, there is no difficulty at all. Direct. The power factor of the circuit is to be determined. So now, therefore, power factor. So power factor is equal to cos of phi. So this is equal to cos of 0, that is equal to 1. Cos 0 is equal to what? 1. Is it not? So at resonance, you see the power factor cos phi is found to be equal to 1. So which of the following options you see here? Option C is equal to 1. Therefore, option C is the correct answer. Okay. So this type of problem has been asked in NEET and AIEEE in the previous years many times. So we have to understand the situation. If you understood, then the problem takes less than a minute to solve. I hope you must have understood well. Fine.